So class 40. So in yesterday's class, we had seen probability and some rules based on it. So just we'll revise it and move on to this one. Probability. So the basic rule of probability and the formula was number of events, number of elements in event upon number of elements in sample space, number of elements in sample space. That's the thing. The next thing we've seen that the probability of any event, between 0 to 1, correct? And summation of all the probabilities of the elements of the sample space. Means, for example, there was an element E1, so this plus E2 plus dot dot dot, summation of all of it is 1. All these elements will belong to E1, comma E2, comma E3, comma dot dot dot, the number of elements. All the elements must be equal to the sample space. Yes, and you know that the probability of event which has 0 is called as a impossible event, and the probability of an event whose probability is 1 is called as a sure event. This is impossible, and this was sure. Okay. Okay. So it was 1, and then we have seen that probability of, where we have stopped or not, probability of A or B will be probability of A plus B. And when we can separate this, if A and B are mutually exclusive, then probability of A plus B equals to probability of A plus probability of B. That's the thing. Yes. Now question comes. The question is, if A and B are not mutually exclusive, then what? How we will find probability of A or B, or you can write it as probability of A plus B. Just a minute, Zaid. Just a minute. I'll take. I'm receiving a call. Okay, I'll mute it. Just a minute. Okay, okay, I'm back, Zay. One of my friends is gone for the Umrah. His video call was there from Makkah. Okay. So what the question is, how we will find A and B? So first of all, we need to see what is the intersection means. For suppose A is this and B is this.
All right.
A, B, C, D. I write in small letters and A, E, E, F, G, D. E, F, G, D. Now this D is common. So how we will write A and B? If I want to write A and B, so how it will be? A, U known as intersection B. Or you can say in terms of A and B, if we write, so it will be C here. Okay, it is this. See. First, I'll just give you an explanation. The textbook, it has explained very drastically. That's the reason I'm explaining you first with the Venn diagram. Then see here. This here D will lie. Yes or no? This part is known as A intersection B, where both the things are common. Where both the things are common. Yes or no? Right? This is A and this is B. And this part is known as A intersection B. It can happen that if we draw A and B, no thing is common. For example, A, B, if A is A, B, C, D and B is E, F, G, H. So here no thing is common. We can draw this separately. Here we cannot draw this separately. Yes or no? This is the Venn diagram for A and B. And here also it is a Venn diagram for A and B where A and B are different. They don't have a single element in common. We can make very far also. For suppose here is A
Mhm.
and the very far is B. And where does A and B comes? They are whole in a sample space S. Here also they will be in the sample space S because A and B are events, not sample spaces. Or this in Venn diagram, this S is also known as U, which is U is known as universal space. Universal space. Universal space means the collection of all the things that are in the world. The collection of all the sample spaces of all the possible sample spaces. All the possible sample spaces. Okay, that's it. Got it? So now the question comes if, for suppose this is A, B, C, and this is D for suppose, and E, F, G for suppose this is our A and B. Now if I want to find probability of A or B, so what I'll do? Yesterday we had seen one example. I'll write here A equals to A, B, C, D, C, D, and B equals to E, D, E, F, G. Okay, and my S is equals to my sample space A, B, C, D, E, F, G, H, I, J, for example. Okay. So now what will be A or B? Yesterday we have seen probability of A or B is not equals to probability of A or probability of B. I am writing in terms of or. It can also be written as probability of A plus B is not equal to probability of A plus probability of B when they are not mutually exclusive. So what we need to do now, just we will calculate. See what is probability of A plus B. First we'll see here. What will be the probability of A plus B? So what will be A plus B? See here. A plus B. A plus B means I'll write here A plus B. What will be the set of A plus B? First I'll calculate probability of A. What is probability of A? It is 1, 2, 3, 4. 4 upon how many elements are there in sample space? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 4 upon 10. Probability of B, I'll write it here. Probability of B, it will be 1, 2, 3, 4. This will also be 4 upon 10. Okay. 10 are only there. Na? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? Yes, 10 are only there. 4 upon 10. And what will be A plus B? It will be A, B, C, D, E, F, and G. See, D was repeating 2 times, but we do not write repeated element. I've told you. In a sample space or an event, one element is repeated uniquely if it is written. If it is repeated also, we consider one time. So what will be the probability of A plus B? See, it is 1, 2, 3, 4, 5, 6, 7. It is 7 by 10. Yes or no? So here I'll do it. So probability of A plus B is 7 upon 10. And probability of A plus probability of B is near about 8 by 10. Yes or no? Which is 4 by 10 plus 4 by 10. So you can see that these two are not equal. Yes, but there is a formula for not mutually exclusive. Probability of A plus B equals to, when it will be equal to, when, what we'll do, see here. First I'll do it and then explain you. See here. See, if I write probability of A plus probability of B. Okay, see, when I am adding these two sets, see, when I'm adding probability of A plus probability of B, what is happening? This is the whole A, correct? Plus probability of B when I'm added. So what is the addition means? This plus this. See, this was the first time also, and this was the second time also. This part, this intersection part is repeated two times in the addition. Is repeated two times when we are adding. When we are adding. So what we need to do to remove, we want this intersection part one time. See, one it is coming when we are adding this, and one it is coming when we are adding this. Yes or no, Zaid? Is this clear? This thing must be understood. It is very important to see this thing. This intersection part, the D part, it is repeating both. Yes or no? Tell me. Okay, are you back? There was some problem?
Yeah, internet.
Okay. So, okay. So,
Yeah.
shall I repeat the things? Till where were you? Here you were there? This,
Yeah,
when I've written this, you
just
were there?
yeah, somewhere in between that.
Okay, I'll repeat it once more. What I want to explain you is that. So I repeat it once more. So when we are adding this probability of A plus B, it is not equal to
Mhm.
probability of A and probability of B. You can see that. You have to observe this. See, probability of A plus B. What is probability of A plus B? It is 7
Mhm.
by 10. Yes. And what is probability of A plus
Yeah.
probability of B? It is 8 by 10.
Wait on time.
Correct? So
Mhm.
this one, this part is greater than this. Means something more is coming here. Something more is coming here. Yes or no? That's the reason
Mhm.
it is 8 by 10. It is around, you can say 80%. Here it is coming 70%. So means something more is coming here. So we need to observe this. See. So this, for suppose this is A, and for suppose this is B. When we are adding A plus B, what is happening? A plus B. I have added A plus B. Yes or no? So when adding, see,
Mhm.
this is A. I'm drawing like this line, and this is B. Yes or no? So
Mhm.
see,
Yeah.
this part, this intersection part, so A intersection B is coming two times. Yes or no? When I am taking A
Yeah.
also and when I am taking B also. Yes or no?
Mhm.
This, so we need to, this intersection part. This intersection part is coming two times. Once with A, once with A, and the other with B. With
Yeah.
B.
I can
But
understand that.
yes, but we want it one time. But we want it one time. So what we need to do? We need to
Mhm.
subtract from probability of A plus probability of B. We need to subtract the intersection of A intersection B. We need to subtract
Yeah.
probability of A intersection B. So what is A intersection B? You know D for us. So what will be the probability of D? So what will the probability of A intersection B? So it will be 1 upon 10. Yes or no? So see,
Yeah.
when we add probability of B minus probability of A intersection B. So it will be 4 by 10 plus 4 by 10 minus 1 by 10. So what it is coming? 7 by 10. Yes or no? which is equals to probability of A plus B. So we had come to a formula when A and B, when A and B are not disjoint, not disjoint. There is a second word we had seen yesterday for disjoint. That was not mutually exclusive. Not mutually disjoint means mutually exclusive. Mutually exclusive. Then we have a formula. Then we have a formula, and this is a general formula as well. Why I am saying it general? General formula. I explain it. General formula for plus for addition. Addition.
Mm-hmm.
What it is? Sometimes in some reference books it is written as A union B, which is equals to probability of A plus probability of B minus probability of A intersection B. And we are or is also termed as union. This is union.
Mm-hmm.
Union and is also termed as intersection. The symbol is this. I'll remove this line or you will without line. This is termed as intersection.
Yeah.
Okay. So this is taken for addition, and I don't remember the sign for and. We'll see it in the textbook if he has given any sign. And we can also write this probability of A plus B equals to probability of A plus probability of B minus probability of A intersection B. Why I am saying it is as general? See, when for see, this is a general formula. You can remember the general one. For I'm explaining why it is general. Why it is general. For A and B are mutually exclusive. If suppose they are mutually exclusive, then can we use this formula? I have told general, so we can use this formula. Why we can use this formula? We know that A intersection B will be phi. Will be phi, yes or no? Right? For mutual, and probability of A intersection B will be phi means 0 upon 10 means 0, yes or no? So we can directly write probability of A plus B equals to probability of A plus probability of B minus probability of A intersection B. And you know what is the probability of A intersection B? It is 0. Minus 0. And 0 has no, what you will say, effect on the output. Understood how this formula came? So he has given the special case one, and then he has given the general. This is the general formula. Is it clear now?
Yeah.
Ah, that's good. Okay, now we'll go on to the textbook. Okay, come on. That was the thing that I need to explain you. This was very important. See, Venn diagram and all is given afterwards, but we have seen it first only. So it will be beneficial for us. Okay, first we need to do the examples of yesterday's component and all. Component and all is clear. See, I'll give you the Venn diagram of component also. Here it ends. Component Venn diagram, for example, component. What is the component? So I've told you whenever you are drawing A, okay? This is A. So there is a universal side always outside. This is always there. This is always there in Venn diagram. Okay, whenever you are representing a set and a sample space, this is a universal set. This box one. So for suppose this is A, yes or no? The whole circle one, correct?
Yeah.
The A complement is the outside one, other than A. The whole U leaving the A. Understood? This is A complement. Leaving A, if we cancel it, I can draw one more diagram. This is A complement and this is A. A complement is leaving the whole A. That is the shaded part is A complement and the left part is A. So leaving A, what we do, that's the A complement. That's the thing. So complement is also clear. We'll look on to one example that's given in the text. Okay. Come on, read this one. Suppose you tear open the corner of a bag of M&M's milk chocolate candies and pour one candy into your hand and observe the color. According to Marx Inclusive, the maker of M&Ms, the probability model for a big from its Cleveland factory is. Means what is the probability is given here. We'll take it on to our boards. Okay. So what he has told, what he has given a probability model. The whole probability means the probability of blue color candy to fall is 0.207. Likewise, probability of orange candy is 0.205. Probability of green candy is 0.196. Probability of yellow candy is 0.135, and so on. There is okay. So explain why this is a valid probability model. So for a probability model, we have seen some conditions. See, I'll just take it here also on our board also, that basic probability rules. So all these rules must match. See, there are only two rules, by the way, you have to see, but I'll take this on our board so it will be very much clear. I'll explain you, means write down also, not just explain. What are the basically rules? I'll mark it down. That see, this is rule number 1 and this is rule number 2. No, that's not rule number 2. Sorry. This is rule number 1 and rule number 2. Wait, I'll just give you some what here when I have explained a probability model. Probability models. I'll write it first. Let it be. I'll write it to be more clear. Okay, there are two rules. There are two rules. There are there. Remember this. It is very important. It comes in entrance exam also. It comes in SAT and all. There are basically two rules. Two rules for a model to be a probability model. For a model to be a correct probability. What are the two rules, by the way? First is the probability of every outcome, you can say, in the sample space, or you can say the event. Outcome or event, you can use any word, outcome or event, must be between 0 and 1. What does this mean? I'll elaborate this. It means it cannot be negative. It cannot be negative. Means less than 0. And cannot be more than 1.
Okay.
More than. I'm talking about specific event, does it? Specific event. Okay. More than 1. It can be equal to 1. Cannot be more than 1. Correct? And is always between, and is always between. I'll again repeat is 0 and 1. That's the same thing that I've written up, between 0 and 1. Same thing I've repeated here. It can be 0, it can be 1. Not greater than 1, not less than 1. And the second rule is the sum of the probabilities, the sum of the probabilities of all the outcomes. All the outcomes means all the outcomes that are in the sample space. All the outcomes, the sum of the probabilities of all the outcomes is always equal to 1. Is always equal to 1. Not a minute difference should be there. Is always equal to 1. These two things I have to verify. So first of all, we'll go on to our question. See here, this is our all outcomes. Yes or no in the sample space? There are this color candies. So you can see the probability all are between 0 and 1. Yes or no? And now we have to, for the first rule is verified. So we'll write in the sentence form also. So here, the first rule that the probability of all the outcomes are between 0 and 1 is verified. Now we need to go on to the second rule. We need to add all the probabilities of the outcome. Means 0.207 plus 0.205 plus 0.198 plus 0.135 plus 0.131 plus 0.124, and see that is it equal to, I'm putting a question mark on the equal to, is it equal to 1 or not. So we'll add it. Okay, so it's 0.207 plus 0.205 plus 0.18 plus 198 plus 0.135 plus 0.131 plus 0.124 equals to. See how much it's coming, Zaid?
What?
How much it's coming, the addition of all the probabilities? 1, correct?
It is 1, right? Yeah.
Yeah, so we can write it here. So the second rule also verified. So it is a correct probability model. So it is a correct probability model. Yes or no, Zaid? Model. You can write in one statement also that it is a correct valid probability model because the probability of all the outcomes of the sample space is between 0 and 1, and the addition of all the probabilities of the outcome, the summation is 1. Is it clear?
Yeah.
Okay, now second question is very interesting. See, find the probability that you don't get blue. When you see a negative statement, don't get blue, what you need to do? Don't get blue matlab, what does it mean? What I'll do, I'll copy this again. Leave this explanation here. Copy because the question is very interesting, by the way. I'll copy this again. Okay. So what he's telling, don't get a blue. Don't get a blue means he gets orange, green, yellow, red, and brown. He can get all this. So what we need to do, what we can do, we can find the probability of orange or green or yellow or red or blue. Yes or no? It must not. But doing so much tedious task, what we'll do? Probability of don't blue. Correct? We have to find don't blue. Correct? What I'll do? How I'll find 1 minus using the complement rule. This is probability of B complement. So what it will be 1 minus probability of blue. Probability of blue. Yes or no?
Yeah.
Correct. So we need to find probability of blue first of all. So what will be the probability of blue? It is around 0.207. 0.207. Correct? 207. So what will be the probability of blue complement? So it will be 1 minus 0.207. So it will be 0. I think 793. Yes or no? Correct?
Yeah.
So that blue complement. And you can verify it. See, you can verify it when your probability of orange or green or yellow or red, you can add all these probability of orange plus, because they are mutually exclusive. Why they are mutually exclusive? Because blue and orange blue and orange orange and green does not have anything common. Green and yellow does not have anything common. Or yellow and red and brown, no one of them have anything in common. Correct? So you can directly add by the principle. So what you will get 0.793. You can see it by adding also as a home. Okay, that's the thing. Now next one. Okay, now next the question is, what's the probability that you get an orange or a brown M&M? Probability of orange or brown. So it will be probability of orange plus brown. So can we write probability of orange plus probability of brown? Yes. 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 Why? Because orange and brown, there is no color in common between orange and brown. They are mutually exclusive. So it will be 0.124 plus 0.124. 205. So the probability will be 923.
3.929.
32 like that.
32.9%.
Yeah, that's 32.9. Correct. Very good. Was it interesting, by the way?
Yeah.
Yeah.
Yeah, it's very
I'll
interesting.
just take a 2 minutes break. I'll just drink water because here
Mhm.
it's night. You are fasting, by the way. Sorry.
Yeah. Okay.
Okay. Are you done?
Yep.
Hello. Yes, I'm back. Yes. Okay.
Mhm.
You are there? Okay. So we have seen all this. We will solve this example also as it's very interesting probability. This is my very favorite subject in statistics, probability and its calculations. Okay. Suppose we choose an American adult at random, define two events. So there we are choosing an American adult at random. Okay, so A, the person has cholesterol level of 224/40 milligrams per daily deciliter of blood or above. High cholesterol means A is the probability that person has 240 milligrams or above, 240 or above cholesterol. and B, that the person cholesterol has a cholesterol level between 200 to 240. Between means 240 is excluded because it is less than. Okay. Borderline high cholesterol. According to the American Heart Association, probability of A is 0.16, probability of B is 0.29. Okay. So explain why events A and B are mutually exclusive. Why events A and B are mutually exclusive. Just a minute. Suppose you have chosen American learner. So we have to, according to American, probability of 0.16, probability of B is 0.29. Explain why events A and B are mutually exclusive. So what we need to do, explain why events. How can we explain with A and B? So okay, you can tell why they're mutually exclusive. Not depending on this, but depending on this. Why? This is 240 greater than 240, greater than 240, and it is less than 240. Means there is no intersection. Yes or no? For suppose a person has a cholesterol level 255. So for suppose P1, where will he go? Here. For suppose P2 have 240. So here it will come P2. Yes, it will not go here because it is greater than, no, sorry, P2 will go here, sorry, because 2, wait a minute, P2, P2 will P1 and P2. Why? Because here, if a person has P3 has 239, so it will come here, 239. Okay, got it? So there will be no common P3, no commonness in this. Therefore, they are mutually exclusive because no common person will come in both. Yes or no, Zaid? Can you give me a condition where it will not be mutually exclusive? So I can tell that A is greater than 240, okay, and B is less than 230, less than 230. So the when A intersection B is considered, all the person ranging between 230, between 230 and 240, between 230 and 240 will come here. Yes or no? Because see, it is great. I'll draw a number line and explain it. This is for suppose 240 and this is for suppose 230. Greater than 240 is all year A, correct? Year A. Year A.
Yeah,
correct? And
they never intersect with each other.
correct. And here it is B. I'll draw this shape like this. This shape like this. Okay.
B doesn't intersect, it's less than.
Oh yes, sorry. B is less than. Okay, sorry. I have to change the condition.
Oh
Yes.
wait, they do intersect, so they are not mutually exclusive.
Yes. Now it will not intersect. Yes or no? Now, because greater than 4. So what
Yeah.
is the intersection? This part. Yes or no? All this will fall in linear. Correct? We can give one more condition. What I want to give, less than 240 and B is greater than 240. Yeah, greater than 230. So see here, see. This is my number I. This is 240 and this is 230. Okay. So less than 240 means here. Correct? Less than. And greater than 230 means here. Yes or no? So this part is common in both A and B. Yes or no? So they are not mutually exclusive. Understood the condition? You need to explain it on the condition. Yes or no? As they have given the condition here. Got it, Zaid? Yeah. Yeah. So next is say in plain language what the event A or B is. So what will be the event A or B? So A or B. In simple language, we have to say A or B means A plus B. So the person, I'll write here the person having the cholesterol level greater than 240, greater than 240 or less than 240. Yes or no? It is A or B or not? In the simple language, correct? Got that, Zay? Greater than 240, like see here. I'm writing as greater than 240 means here, or less than 240. Less than 240 means here. It is A or B. No one thing is common. Correct? Yes or no?
Yes.
Yeah, that's the thing. What I'm changing it? I have the question. Now the third is, let C be the event that a person chosen has cholesterol level below 220 gram normal cholesterol. Find C. Oh, C be the event that the person chosen has a cholesterol level below 200 ml. Oh, that means there are three events in the sample space. For suppose A, B, and C. There are three chances of the sample space. Only three possible chances. There is no D, there is no E, there are only three. So we know that probability of A plus probability of B plus probability of C. All the outcomes, probability addition is 1. Yes or no, Zaid?
Mhm.
So 0.16 plus 0.29 plus I don't know the probability of C, but I know that the addition of all them is 1. So probability of C will be 1 minus 0.16 minus 0.29. So what will be the answer? It will be, first we'll need to add 1 minus 6, 5, 1, 3, 4. For 5, it will be 0.55. 0.5. Understood?
Mhm.
Right?
Yeah.
Got that? Was it interesting or not?
Mm.
Yeah.
Yeah, it was interesting.
Yeah, now it comes this. See this. I have explained you all this in our starting of the class only. Two-way tables, probability, and the general addition rule. See, he has given here. I have not read this further, but I know the thing. Think that this is known as general addition rule. This is the general addition rule. This is a specific one. This one is a specific one when they are mutually exclusive. If they are no mutually exclusive, then the general one I have shown you how it comes and how it is. Okay, now we will do this
Mm.
activity. First of all, you can read this. So this is general. How can we find probability or A on B when two events are not mutually exclusive? The question here again he is giving. So here two-way table is there. Student in a college statistics class wanted to find out how many common it is for young adults to have their ears pierced. They recorded data on the two variables, gender and whether or not the student had a pierced ear. For all 178 people in the class, the two-way table summarizes the data. So what is the two-way table? See, for suppose I'll take this on our board. Have I taken the whole? So students in a college statistics class want to find out. Okay, we have read the question. Suppose we choose a student from a class at random, defined A as getting a male student and even B getting a student with a pierced ear. Okay, so A is getting a student, male student. So what will be the probability say? Probability of A getting a male student, probability of A. Now see this, it is glitching the pen. Probability of A will be male. How many male are there? Total male 90. Correct. It will be 90. Correct. Yes, 90 upon total number
Yeah.
178. Correct. So I'll do the calculation here.
Mm-hmm.
90
That would
divided by
be
178.
49.
No,
Mm. Mm.
0.5056. It is around 50.56%.
But 90 divided by 180 is 50.
Yes, yes. Yeah, correct.
Uh,
That is it.
that's something
Probability of B,
wrong.
90 divided by 178, does it? It is correct. As the denominator has decreased,
Oh,
if the
yeah,
number
wait,
has
never
increased.
mind.
Correct?
Never mind. Yeah.
Yeah,
Yeah,
yeah.
it's correct.
Yeah, yeah. Sometimes it happens. Yes. Sometimes it happens with me that knowing the in class here in India when I'm teaching lower classes, sometimes it happens that I have taught something different. So I think how it has happened. That's the human case. So what's B? Even B as getting a student with pierced ear. Student
Mhm.
with pierced ear. So what will the probability of it, by the way? So it will be pierced here is,
Mhm.
yes, see here, pierced here, yes, 103 upon 78. Oh, 178, 178. So 103 upon 178. 103 divided by 178. So what it is? 0.5786. 0.5786, which is around 57.86%. Yes or no, say? Correct?
Mm-hmm. Yeah.
Now that's the game. We have find probability of A, probability of B. Yes or no? We have the answer of it.
Mm-hmm.
See, make a habit. As you write the event, find its probability. Okay, the half of the things will be solved there. You will also get the general idea of the difficult question, how to solve it. Okay, we have done. Okay, now what we need to find, find probability of A and B. This is very interesting. Probability of A and B.
Mm-hmm.
What I've told you. What does and means? And means intersection. Yes or no?
Yeah.
Section. Correct. So I need to find probability of A and B. Means probability of A intersection B means I write in wording probability of male student having pierced ear. Yes or no, Zed?
Yeah.
Yeah. So your table does our task very easy. We can find this with this heading, male student having pierced ear. So where does the table give us the value? Tell me in the table. Male student having pierced ear. Where it is here? Yes or no? It is male student
Mm-hmm.
having pierced ear. So how much it is? 19. Yes or no?
Yeah.
19 upon 178. So what will be the answer?
Mm-hmm.
19 divided by 178. It is
Mm-hmm.
0.1067, which is around 10.67%. Yes or no?
Mm-hmm.
Correct? That's the thing. Now there's a
Yeah.
question. This was the first important thing. Now this is the
Mm-hmm.
last important thing. Probability of A or B. Now you need to think. Means probability of A plus B. So are they mutually exclusive? Are they mutually exclusive? The table shows they are not mutually exclusive. Yes or no?
Mm-hmm. No, no,
There is
they're
some
not.
intersection. Correct? So
Yeah,
what will be the probability
exactly.
of A plus B? So it will be probability of, we'll add the general one. We'll always use the general one. Please remember, we'll never use the specific
Mm-hmm.
one, A intersection B. So what is the probability of A here? Have you find it? 50, 50.56%, 50.56% plus probability of B. It is 57 point, and you can see 86%. And if we are adding these two only, if you have made a mistake, you add this two only in the exam, you can get a simple idea that it is around 107 point 108 point
That's
something
above
zero
the
five
one.
percent. It is above one. It cannot happen. So it's wrong. So we need to minus. Oh, I have put plus.
It's not mutually exclusive.
Yeah, correct. It's not mutually exclusive. You can get an idea from there also. Minus.
Mm-hmm.
What is intersection? 10.67.
Yeah.
7%. I'll erase this also, down one. What will be the final answer, by the way?
Mm-hmm.
Equals to, we'll do it on calci. 50.56 minus, minus not plus, plus 57, 57.86. Enter, minus 10.67. It is 97 point, how much it has come? 75%. So it is around 0.9775. Got that, Zay? That's the thing.
Mm-hmm.
Yeah. All was understood, all the things that we had gone through.
Yeah.
Yeah,
Yeah,
so
I
that's the thing. He
understood.
has explained the whole example here. So he has taken in the form of numbers in fraction that we have converted into what we have converted into percentage, or you can say the general probability in decimal numbers. See, he's given the general rule of addition. We had seen this further on in the starting class. Was that interesting or not? Today's class.
Yeah, that's interesting. Yeah.
Yeah. Now we'll do one more example. Okay. Come on. See, read a survey of all residents in a large apartment complex reveals that 68% use Facebook, 28% use Instagram, and 25% uses both. Come on, we'll do one. Okay. Is for example, he's telling that probability of Facebook or complex reveals that 68 Facebook users is 68%, means 0.68. Probability of Instagram users is 0.25. I'll write first 25%. 25%, that's 0.25. And probability of both means F intersection I means, or you can write probability of F and I. That's the thing. Both means that uses both is 28 it is. Here it is 28. So 0.28. And it is 0.25 here. So means 25%.
Mm-hmm.
So what we need to find? What is the probability a person uses Facebook or uses Instagram? So it's asking probability of F union I. Union is for or, F or I. So what is the formula? It is not mutually exclusive. Why? Because both probability is given intersection. So probability of F plus probability of I plus minus C. This remember probability of F or I. So it is F is 0.68 plus 0.28 minus 0.25. So what I'll simply do, first I'll do the subtraction. So it is, we are left with 0.68 plus 0.03. Yes, and when we'll add, it will be 0.72, which is 72%. Got that, Zay?
Mm-hmm.
F or I?
Yeah,
That's the thing
got
all over
that.
for today.
Mm-hmm.
Come on, that we have finished the general rule of probability of addition. You can try this example for homework. If any difficulty, we'll discuss it tomorrow, and we'll discuss this sum also tomorrow. This one is important sum.
Mm-hmm.
And then we'll start with Venn diagrams. Venn diagram I've explained you earlier only. This I'll give you the different situations where Venn diagram differs. Means all the situations where Venn diagrams are used and a different Venn diagrams for different conditions. Intersection, complement, minus, and all that. Okay. Tomorrow we'll see it.
Mm-hmm.
Is it clear? Practice this one.
Yeah.
See, intersection and union also we have done. The things that are coming further, alhamdulillah, this is very strong. This is very strong in statistics. And the subject is very easy in your book. So we have finished with 5.2, by the way. Tomorrow we'll complete it, discussing all the things. Is it clear now? Okay. Shall I
Yeah.
stop? Yesterday's recording I've
Mm-hmm.
shared. This is the weekend. You told me that you will share the test after the weekend. So I am seeking the test, and inshallah tomorrow I'll forward you the test or based on chapter 3. And we'll also
Mm-hmm.
discuss the sum tomorrow of chapter 3, so that it becomes a revision point. Okay.
Okay.
Assalamu alaikum. How's your
Walaikum
Ramzan going on?
salam.
All well?
Oh well. Good.
Yeah. Say salam to your mother, father, and Zoya also. Okay.
Mm-hmm. All right.
Assalamu alaikum.
Walaikum salam.
Hafiz.
Office.